Hello, today I will present my industrial hygiene study focusing on temperature measurement and heat stress in a palm oil mill factory. I will explain the hazard, exposure assessment, measurement process, and also the control measures. But first of all, my name is Qeeden bin Aldin. I'm a student from SCSWK2400114 College Sarawak, and currently I'm taking a diploma in occupational safety and health. This presentation for industrial hygiene subject OSHI3714, and the lecturer for the subject is Madam Roslyn binti Haji Basran. So first let's go through the introduction. A palm oil mill factory processes fresh fruit bunch, also known as FFB, into crude palm oil through several stages such as sterilization, pressing, and clarification. These processes involve high temperature and steam. In industrial hygiene, we focus on identifying and controlling hazards that may affect workers' health. In this industry, common hazards include heat stress, steam exposure, noise, and chemical exposure. The industry hazard, heat stress. In this case study, we focus on heat stress as the main hazard. Heat is generated from boilers, steam sterilizers, and hot machinery. Workers are exposed to high temperature and humidity, especially in enclosed areas. If not controlled, heat stress can cause serious health effects, such as heat exhaustion, cramps, and even heat stroke. Exposure assessment. Exposure to heat occurs through thermal stress, where workers are affected by high temperature and humidity. The body cannot cool down effectively. Workers at higher risk include boiler operators, sterilization workers, and also the maintenance staff. We can assess exposure using qualitative methods like observation and walkthrough surveys, and quantitative methods such as WBGT measurement. Factors like long working hours, daily exposure, and poor ventilation increase the risk. To measure the heat stress, we use a WBGT meter, which stands for wet bulb globe temperature. This instrument measures air temperature, humidity, and radiant heat, giving a more accurate representation of heat stress compared to normal thermometers. It is also widely used as a standard tool in industrial hygiene. Measurement procedure. So the measurement process was carried out step by step. First, the WBGT meter was checked and prepared. The wet bulb wick was moistened to ensure accurate humidity readings. Then, the device was placed at the worker's breathing height, around 1.1 to 1.5 meters. It was positioned near the work area, such as the boiler section, and left for about 10 to 15 minutes to stabilize. Finally, the readings were recorded once they became stable. Safety precautions were also taken to avoid heat exposure. So then, the results were compared with standard guidelines such as ACGIS threshold limit value and also OSHA guidelines. These standards provide safe exposure limits based on the type of work, whether light, moderate, or heavy. This helps determine if the working environment is safe or if control measures are required. So to reduce the heat stress, we apply the hierarchy of control. Engineering controls include improving ventilation and installing cooling systems such as cooling fans. Administrative controls involve scheduling work rest cycles, rotating workers, and providing training. Lastly, PPE or personal protective equipment such as cooling vests and proper hydration helps protect workers. So we have reached to the conclusion. In conclusion, heat stress is a significant hazard in palm oil mill factories. Proper exposure assessment using WBGT is important to evaluate risk levels. By implementing effective control measures, we can reduce heat-related risks and improve worker safety and productivity. So these are the references used in my study, including guidelines from SCGIS, OSHA, and also DOSH Malaysia. While this section shows additional information such as the WBGT diagrams and the production line of a palm oil mill for my presentation. So that's all from me. Thank you very much for your time.